Objective 9, More Limits, Part 2. Uh, we're going to return to our difference quotient and then applying a limit to it. This we saw last chapter. This is actually a definition of a derivative and a fancy way of calculating slope. You'll learn more about the theory behind that in Calculus 1. For now, think of this as a way of learning a lot of very useful algebra. We're going to start with f of x equals 2 over x. That's a basic reciprocal function. And I'll draw you a rough sketch so you can visualize what's going on. It goes through the point 1, 2, over 1 up 2, and also through the point negative 1, negative 2. And it is looks like this. It's one of those rational functions. It's also a rotated hyperbola, as are those other rational functions. You can rotate this 45 degrees, and it would actually be a second degree function. Right now it's xy equals 2, basically. But it would be an x squared minus y squared or y squared minus x squared function, depending on how you rotate that. The algebra is peculiar to this function, so that's why we're going through it. F of x plus h is 2 divided by x plus h minus original copy of f of x, 2 over x, and then we want to divide by h. And looking at this limit, as h goes to 0, if you put 0 in here, we'd have division by 0. The numerator would be 0. 0 divided by 0 is indeterminate. Somehow we have to subtract these so that we can divide that h out. Get rid of the indeterminacy. Well, what we do is this. 2 over 2 plus h times x times x over x minus 2 over x times x plus h over x plus h over h. That'll give us an LCD. The LCD is x plus h times x, or x times x plus h, same thing. That will give us, you can actually multiply these two and get 2x over x plus h times x minus, you have to distribute the 2 through, 2x plus 2h over x plus h, all divided by h. Notice I keep the denominators factored. Eventually we're going to cancel something out, so we'll keep it in factored form. No point in multiplying it out. Now when we subtract, you have to subtract 2x, subtract 2h, and so we get 2x minus 2x minus 2h over x times x plus h. Now this, we're going to invert and multiply. It becomes times 1 over h. Now is an appropriate time to do this. And then the next step, we can cancel out that. And it gives us negative 2h over x times 1 over h. That's an h there. Then we cancel out the h's, and we have negative 2 over x that's just that. Now, if you look forward, our goal eventually is to plug 0 in for h and not get an indeterminate form. If you plug in 0, negative 2 over x times x. Perfectly good. We're not dividing by 0. And so let's do that over here. And we get negative 2 over x squared. That's our final answer. We mentioned before, this gives you slope. It gives you the slope of this function. Okay, if you were to draw like a tangent line right here, this is point 1, 2. First of all, just by the geometry, you know the slope is negative. It's a downward sloping function. And if you guess the slope of negative 2, that's right. All you have to do is take this 1, substitute it here. Negative 2 over 1 squared is negative 2. And likewise, if you pick a point over here, for instance, negative 1, negative 2, you can see by symmetry actually, you actually get the same slope as we had here. And sure enough, if you plug negative 1 in here, negative 2, negative 1 squared is 1, negative 2 over 1 is 2, you get the same slope. Here and here, the slope is negative 2, just the same both places. That's what we're doing. The whole point of this is to calculate rate of change. It's a pretty important subject in physical sciences. So, okay, that's all for this.